Good morning, students. I am Nidhishree Pagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we studied regarding combination of resistors. We also dealt or studied regarding certain numerical problems on series combination. In today's class, we are going to study about the other concept. So when you observe your surroundings, the electrical appliances in your surroundings, for example, the fan, the television, the bulb, everything. So whenever you run these appliances for a longer time, when you touch them, you can feel hot. It is due to the generation of heat in that electrical circuit of those electrical appliances. So how this heat is generated, where we will use it, that all we are going to study in today's class. So let me take an example of a simple circuit. So this circuit will be consisting of a battery, okay, then a key, then let us consider a very simple circuit which will be consisting of a bulb. Fine. So whenever the switch is on, the filament inside the bulb, which we call tungsten, it will get heated up. And when it heats, that heat energy will be converted into light energy. So here in this case, what is happening? First, electrical energy is flowing through the circuit, that is the current I, okay. Electrical energy, once it gets electrical energy, it will utilize it for heat energy is created, and once the filament gets heated up, it gives us light, so it is a light energy. So like this heating effect of electric current will be seen in our daily life. So what actually happens, how heat is released during or in the electrical appliances or while passing of the electric current. Let us see that. So what happens actually, let us consider again a circuit, a simple circuit. Okay, so let me consider a conductor. Fine. So inside the conductor we will be having, when the switch is on, the electrons will flow, right? So when the electrons will flow, we know that they will collide with the atoms of the impurities present inside the conductor. So when these electrons will collide with one another, there will be a loss of energy. There will be a loss of energy. So this loss of energy will be in the form of heat. This loss of energy will be in the form of heat. That is why we can call it as heating effect of electric current. So what is heating effect of electric current? When the current I is flowing through the circuit, the collision of electrons with the atoms of a conductor or with the impurities of a conductor loses heat or releases the energy in the form of heat, which is called as heating effect of electric current. So what this heating effect of electric current is, it is nothing but the work done. This principle will be applied for electrical heaters, for the, we can say, the iron machine. So for most of the electrical appliances, this principle has been used. Okay, so let us see the formula for the heating effect of electric current. That is the formula for heat energy. Okay, now we know that we should consider a circuit where current I is flowing through a circuit. Okay, so we have a battery here which has a voltage V, So the current is carrying the charge Q. So we know that I is equal to Q by T, which implies the charge which is being carrying throughout the circuit will be equal to the product of current and time. Q is equal to EI into T. So let us name this equation as 1. Fine. So now, when we come across the potential difference here, difference in the circuit. So we know that V is equal to W by Q. As we want work done here, so we will solve W is equal to V into Q. So this is equation number 2. So what is work done here? Work done is nothing but the heat energy. So here, as it is the heat energy generated during the collision. So let us first simplify this. Let us substitute the equation 1 into 2. So W is equal to V into I into T. So as work done will be equal to, heat generated, okay. So W is replaced by H. H is nothing but heat generated is equal to V into I into T. Okay, this is equation number 3. So we know that according to Ohm's law, okay, so V is equal to I into R. V is directly proportional to I, where R will be the constant. So this is equation number 4. Let me substitute equation number 4 in equation number 3. Then H is equal to V means I into R into IT. So it will be I square R into T. So this equation where the heat energy released, heating effect released during the flow of electric current, it will be inversely proportional to the square of the current in the circuit, will be directly proportional to the square of the current in the circuit, will be directly proportional to the resistance in the circuit, and will be directly proportional to the time of the flow of electric current. Again we can apply. So this equation is called as Joule's heat energy. So it is called as Joule's law of heating. It is called as Joule's law of heating. Okay, this can again be simplified by using Ohm's law. So H is equal to I can be written as V by R, right? So here V square by R square into R into T. R get cancelled. We will get V square by R into T. So this can also become formula. So we have I square RT, VIT and V square by R into T. So this is regarding heating effect of electric current. In the next session or in the upcoming video, we are going to discuss the practical applications of this heating effect of electric current. Until then, take care. Have a nice day. Bye-bye.